Hello and welcome to lesson 2 of our behavior of gases unit. This lesson deals with 12.4 and 12.5. So if I were to ask you or tell you that you have 2 liters of a gas at let's say 25 degrees Celsius and it has a pressure of 1.5 atmospheres, would you be able to tell me how much gas you have? How many moles? How many grams? Or what if I asked you how many liters it would take if you had 17 grams of oxygen at 30 degrees Celsius with a pressure of 1 atmosphere. Would you be able to tell me that? Well, soon you will. As we start to look at the ideal gases and the idea of an ideal gas law, we're going to get into a new gas equation called the ideal gas law, and that is PV equals nRT, which should look a little bit different than that combined gas law we just finished, because rather than having 2 units of pressure and 2 units of temperature and 2 units of volume, instead we're working on just pressure, just volume, just temperature, but then we also have this idea of N, or the amount of gas in moles. And so it gives us some different uses to be able to work with for on gases. Once we get a handle on the ideal gas law, we're going to look at 2 other laws, but a little bit more quickly. We're going to talk about Dalton's law, which is just saying that if you have a mixture of gases, each gas contributes part of that overall pressure. And we'll wrap things up by talking about some motion of diffusion. If I were to release, let's say, 17 grams of nitrogen gas, and at the same time I released 17 grams of oxygen gas, which one's going to reach you faster? Which one can move faster? And we'll see an equation with that, and we'll be using some square roots as well. So throughout this chapter, we're going to continue to introduce you some different gas laws. Make sure that your calculators are ready and working just fine so that you can calculate those final answers. So good luck as we wrap up our behavior of gases unit.